Hey everybody, so I hope you're having a great day so far, and today I want to talk about electron configurations. But before I do that, I want to introduce you to my dog. This is Bo. I call him Bo Bear because he looks like a giant brown bear. He's a chocolate lab. He's about 5 or 6 years old, and he weighs about 120 pounds, and he is very lazy, as you can tell. This is what he does almost all day, every day. So I want to talk about electron configurations, and I'm gonna try to go slow because this is a really really out there topic, a really abstract. And when I say abstract, I mean that it's very interesting but very odd. So last week when we were doing our projects, we were talking about this Bohr model of the atom, and according to the scientist named Niels Bohr, he said that the nucleus is positively charged due to the protons. The electrons are negatively charged, so they orbit around the nucleus. And there's been tons of debate over the years, well, how do they orbit around the nucleus, or what pattern do they go in? So Niels Bohr, he said that they just orbit in circles around the nucleus, kind of like planets would around the sun. And they're just constantly, circling around here, and each energy level, which is each circle, can hold so many electrons. And the further away you are from the nucleus, the more energy that these electrons have. So if you think about it like this nucleus is positively charged, and these electrons are positively charged and negatively charged. And if you're out here, you're an electron that's like out here, the nucleus, it just can't hold on to you as tightly because it's being blocked by all these other electrons. So the further away you are from the nucleus, the more energy you have, and you go in circles like so. So the next scientist, his name is Erwin Schrödinger. He did experiments, and he found out that the electron can actually act as both a wave and a particle. So do you remember that weird Ed puzzle that we watched 2 weeks ago with Dr. Quantum? So basically what happened was he shot electrons at like a detector, and he determined that these electrons can both be particles and waves, kind of like light can, which is really, really weird. So this Schrödinger guy, he stated that the electrons, they still orbit at these fixed distances away from the nucleus. So like, let's say that my fist here is the nucleus. The first electron is going to orbit right here, and then the next energy level would be like out here, and then the third energy level would be all the way out here. So again, there are these fixed distances away from the nucleus. But he says that these electrons are not orbiting in these perfect circles like the first guy, Niels Bohr, believed. He says that the electrons are orbiting in these different shapes, and there are 4 different shapes that the electron can orbit in. And if you Google this, you may read up about like Schrödinger's probability density function and all these like out there things. I'm trying to keep it as simple as possible, just because the more you get into this topic, the more and more out there it gets. So again, I'm just going to keep it as simple as I can. So he named his Erwin Schrödinger, he named his model the quantum model of the atom. And he said, remember, that the first shape that the electron can orbit in, or can go around the nucleus in, is a sphere. And he called that the s orbital. So again, if we are orbiting in a spherical shape around the nucleus, we're orbiting in the s sublevel. Okay, so let's talk about this for a second. So we've got the nucleus here. Let's say that my fist is the nucleus, and the electrons are circling or orbiting around the nucleus. The first shape that the electron can be in is going to be this spherical shape. Alright, the second shape is going to be this dumbbell looking shape, and sometimes people like to call it the infinity symbol or a sideways 8. And he called that the p orbital. Why is it the p orbital? Your guess is as good as mine. He just picked out these various letters. So S, I can see it stands for sphere, but P for dumbbell, not really sure. The third shape is going to be this 4-leaf clover shape, and it's down here, and it's called the d orbital. Again, why d? No idea. And then finally, the F sublevel is going to be this double 4-leaf clover. So it's going to be one 4-leaf clover here, and then there's going to be another one on top of it that's kind of superimposed onto it. So again, we're talking about how do the electrons orbit around the nucleus. So when we're orbiting in the spherical thing, we just go like this, except it's three-dimensional. If you're in the p sub level, then you're going to orbit like this, and the electron is just rapidly racing in this kind of configuration here. If you're in the D level, it can be anywhere within this four-leaf clover. It's just constantly going like this. And then the F sub-level is going to be this crazy shape that looks like two clovers like put on top of each other. So if we're talking about energy levels, and remember energy level is just the distance from the nucleus. It's how far away is that electron orbiting. He says, this Niels Bohr and Schrodinger, they said that these different energy levels can hold different numbers of electrons just because of the amount of space that there is between the electron or where it's orbiting and the nucleus. So the first energy level can only hold 2 electrons, and we talked about this when you did your project. The second energy level can hold 8, the third one can hold 18, the fourth one can hold 32, and then the fifth one can hold 50. Okay, and I'll show you why this is here in a second, but it's just kind of something that you have to memorize these numbers. Alright, so let's talk about the number of electrons in this S, P, D, and F. So we talked about the different energy levels, or the different distances that these electrons are orbiting from the nucleus. So just as the different energy levels can hold different numbers of electrons, each shape can also hold a specific number of electrons. So if we're talking about the S orbital, the S can only hold 2 electrons. So only 2 electrons on each energy level can be orbiting in a spherical shape. After that, they then have to move to the P shape. Remember, the P shape is this dumbbell shape, and 6 can fit there. After we filled all of those up for that energy level, we then go to D, which can hold 10, and then F, which can hold 14. And I know this is weird and odd, and you just have to kind of have a very light grasp on what we're talking about here to do these things called electron configurations. And electron configurations is a way to show how we divide up the electrons between these different energy levels and the sublevels or the shapes. So if you see the words sublevel, orbital, shape, all of those are the same thing, and they're talking about S, P, D, and F. So when we write these electron configurations, we always start out at the bottom and we fill the lowest energy level first. So we're always going to start out with the number 1, and we're going to fill S, and then we'll fill P, and then D, and then F, and so on and so forth. So if you're trying to figure out how many electrons you have to give out, just look at the periodic table, and the number of electrons is going to be equivalent to the atomic number. Alright, so how do I fill in the energy levels? Like if I'm given a certain number of electrons, how in the world can I figure out what do I do, you know? So I'm going to always let you use this diagram, and if you've noticed, you can't really click on this, you can't mess this up, because I've made this the background image, and you can't change this. So this is how it goes, okay? So we start out at 1s, and s can hold 2 electrons. Alright, and since s is, or this first energy level is so close to the nucleus, there isn't enough room for it to have a p sublevel. Alright, so we're going to go 1s, then to 2s, then to 2p, 3s, 3p, 4s, and this is where it gets really weird. Like, I don't know why, but it goes from 4s to 3d. So every time you have a d sublevel, it's going to be 1 behind. And when I say 1 behind, I mean the number at the front is going to be 1 behind the one before it. So after 3d comes 4p, 5s, 4d, 5p, 6s, and now again, here's where it gets weird and creepy, 6s goes to 4f. So the way that I remember this is I hum a little tune in my head to the theme of like Jingle Bells, and it goes 1s2, 2s2, 2p6, 3s2, 3p6, and then it'll get stuck in your head over time, and you'll eventually remember how to fill in these electrons. And I'll sing it during class too, so you can keep up with it. Alright, so it says write the electron configuration for fluorine, and here are the steps that you want to go through when you're trying to write these electron configurations. So you want to figure out how many electrons the element has to give out in the first place. So you're going to do this by looking up the atomic number, because remember the atomic number is going to be equal to the number of electrons. Alright, so after you figure that out, you're going to start out by writing the lowest energy level, which is always 1, and then writing the lowest sub-energy level. So remember, sub-energy level means orbital, sub-level, shape. Alright, so you're going to start out with 1, and then you're going to go 1s. And remember, you can go through this and these little reminders over here to figure out how many each one has. Alright, so you're going to keep going up the diagram by giving out the electrons according to the rules. Alright, so it says the atomic number of fluorine is 9, so fluorine has 9 electrons to give out. So we've got 9 electrons to give out, and we're always going to start out, we're going to write 1, and then remember, the first one we're going to fill in is S, so 1s. Alright, and then you're going to ask yourself, well, how many electrons can S hold? That answer is going to be 2. So you're going to go 1s2, like so. Alright, after 1s, following the little diagram over here, we're going to go to 2s. Alright, so we're going to type 2s, and again, ask yourself how many electrons can S hold, and the answer is 2. So you're going to do 2s. And the way that you do the little superscript is you're going to hold down Control, and then you're going to hit the period, I'm sorry. So I've already given out 4 electrons, okay? So because each one of these little numbers up here, these little exponent numbers, are numbers of electrons. So 2 plus 2 is 4. All right, so now I have 5 electrons to give out. So if you look at this little picture over here, I'm gonna go from 2s to 2p. All right, p can hold up to 6 electrons, but we only have 5 electrons to give out now. So I'm gonna go 2p, and then I'm gonna hold down Control or Command, and then the period, and I'm gonna put 5. Alright, so whenever you get done, these little exponent numbers should equal the total number of electrons that you have to give out. And that's pretty much it for how to write electron configurations. I try to keep this video short, and I try to keep it simple. I'll have another video for the next worksheet. Thanks, have a great day.